thread lifecycle. Once I create an object of class thread and invoke the start method, the thread initializes itself and enters the ready state. Once the thread gets the CPU time, it moves to the running state, from where it may enter blocked, waiting, or sleeping states. On completion of the execution, it enters the dead state, which is much like your process states. Let's look at the thread states once again, along with their method calls. Here I am creating a thread object TomThread. The thread object is now created. Let's call the start method on TomThread. This gets Tom to a ready state, looking for Jerry. Now let's give some CPU time to TomThread. There he goes. As discussed, the thread from a running state may enter blocked, waiting, or sleep states. Let's now send TomThread to bed for n milliseconds by calling the sleep method. Here goes Tom for a sleep. After the n seconds, TomThread is ready to run once again. Now let's put TomThread on an indefinite wait by calling the wait method. Here is Tom sadly looking at his clock. Now let's not make him wait longer. You can break his wait by calling the notify method. Here goes Tom once again to the ready state. Now when can Tom get blocked? Let's also understand that. On performing an input-output operation, the Tom thread may go to a block state. Once the input-output operation is done, Tom comes back to the ready-to-run state. On completion of the thread execution, the Tom thread gets destroyed. It implicitly calls the destroy method. Here is the dead Tom. This was an example to make you understand the different states of a thread. Issues with multithreading. Though threading is efficient, it has some dark sides. Platform dependence. Based on whether the operating system supports time slicing or preemptive scheduling. Serious concurrency issues arise when one thread accesses another thread's objects. Thread execution ordering. Order of thread execution cannot be guaranteed. We will look at some issues as we go forward in the next slides. Sleep method. Thread.sleep is a static method. It delays the executing thread for a specified period of time. Thread.sleep throws an interrupted exception if it is interrupted by another thread. Interrupted exception is a checked exception. Therefore, you need to handle or declare it under the throws section. When a thread is asleep or otherwise blocked on input of some kind, it does not consume CPU time or compete with other threads for processing. Let's look at an example. In this example, I have a class new thread which implements the runnable interface, as you see at line 2. And then I have the method public void run, from where the thread execution begins. In this method, I have a for loop which prints the message child thread and then puts the thread to a sleep for 1000 milliseconds, as you see at line 6. At line 18, I am creating the thread object, passing the runnable object new thread, and starting the same at line 19. Further, I have also put the main thread for a sleep at line 23. Just to add, a Java application starts with a default thread called as main thread. You can find the source code of this example in Java Virtual Guru. You can practice the same.